Okay, today's time is ready. So welcome, hello everyone. Welcome to join today's training. Today's training is about our PLC module, and I will introduce a part of the I/O module. So let's start. Today I will introduce three type modules. The first is expansion module, and the second is the DB module, which is much smaller. And the third is the LCM module, which use the model bus TCP protocol. So you can use this module for other PLC. The first is the expansion module. We start with the name rule of the expansion module. The first is the series name. For the moment, all the series name is LX3V, and here is the number. It means the channel. How many channels for this module? And the last character is the function code. For example, AD here means the analog module. It receives the analog signal and it output the digital signal. Follows are common extension module. You can see we have the digital input module, analog input module, digital output module, both relay and transistors type, and the analog output module. And 4PT is the temperature module. It used with the PT1000 sensor. And the LX3V4TC is the smokable input. It's another temperature module. And there is also a LX3V4LTC. It's same with the 4TC module, but it has the PID function. So you can use the built-in PID control with this module. And then we have the waiting module, the different channel, one channel or two channels, and with different resolution. And the last is the pulse output module. A means advanced and B means basic. They have some function different. So here is the connection with the module to the PLC host. You can see there are 5 modules, and the first module is we set it as a position 0. And then the second module here is a digital input module, so we don't need to set the position number. So the position 1 is the third module here. The fourth module is the same, is the digital output module. So when we use this module, we just named Y, for example, Y50 here. So it don't need to set any position number. And the 5 module here, we need to use position number here. So here is number 2, position 2. When we use this module, we need to use some relative instruction. The first instruction is FROM function from. This function read data from BFM. This is the memory address from the module. And you can see it here. The first parameter is the module number. As I mentioned here, the position 1. So if we want to read the value from 48 module here, the parameter M1, we set K1. M1, we set K0 here. And if we want to read the value from 4LTC module, the parameter M1 is K1. The M2 parameter is the memory addresses. Different type module have the different address for different memory. And parameter third, the D parameter is the start address for stored data. The last parameter is for the data length. As you can see this example, if this is F from K1, K20, D200, and K1, it means when X0 is triggered, PLC reads data from BFM 20 of the first module and store the data in D200. And the data length is 1. In theory, it's about the maximum module can be connected is 16, but I will mention it later. The second relative instruction is to instruction. It's the same, but it's just write data to the module. So you can see this program example. If the X1 triggered, the PLC write data. The data is from D12, 2220, and write it to the first module. And the memory address is BFM24. The data length is 1. And as you can see, there are different types here. TO or DTO. D here means the 32-bit instructions. So if we just use from or to without D, so if the length I set here is 4, here it means DFM1 to 4 transfer D10 to D13. But if I use DFROM and I set the last parameter N is 2, so it also means move the BFM1 to 4, 1 and 4 to D10 to D13. So here is the same if you use different instruction. with D or without D. Next, we move to the BD module. The name rule is the same. The first part is for the series name, but it has a LX3V or LX5V module. And the number here is the channel number, the same, and the function code. For this example, for this LX3V 2AD 2DA BD. BD means the module type. It means this module has two channels, analog input and the two channel digital input. Here is the common DB module for LX3V series. As you can see, it also have the analog input, analog output, and the temperature sensor input, and also have the communicate BD mode. Here is two communication BD board, LX3VRS485 BD and LX3VP ETH BD. These two BD communication BD mode cannot use with LX5V. Besides these two, other BD mode can be used with LX5V. And the follows are LX5V series BD module. The first two is also the communication. It's also for communication. So this two is also cannot use with LX3V. But last can be used with LX3V. This is relative addresses for LX3V. If you use the BD mode with LX3V, you can read the data and the flag bit from each module with this address. So many people ask, if I use LX3V module, how can I connect it with LX5V? Actually, if LX3V module used in LX5V, the BD module just have the different relative addresses. So it's the same. It just have the different address to read the value and the bit flag. And for the LX5V BD, it have another configuration interface. You can see here is a BD module configuration option, and you can see the list of each BD module at the right, and you can double click the module you need and parameter it. The last is for LCM module. LCM is the series name. It means it's a remote module. The number here also means the number of channels and the function code. Now we have the four modules, LCM modules. Digital input module, digital output module, and the varying module, and the temperature module with the thermocouple type K or type J. Sorry, I lost type J here. Let me show you the picture of the LCM module. As you can see it here, this terminal is for the DC 24-volt power supply, and this two is for the series port, and the LCM module use the Modbus RTU protocol. So here is IS485A and 5 IS485B. And you can also see there are 8 DIP switch here. This switch, DIP switch, is for the communication parameters. The last 3 DIP switch is for the baud rate settings, and you can see a different state and matched the different baud rate. So if more is the 6 and the 8 to 8 are all off in off state, the boundary rate is 150,000, 15,000, and 200. And if I want to set the boundary rate is 9,000 and 6,000, I just set the DIP8 is on and the 6, 7, and the 6 are off. And the DIP1 to DIP5 is for the station number. As we know, if I want to communicate with the Modbus RTU protocol, I need to know the slave station number. So the first 5 DIP switch is for setting the station number here, and you can refer to this table. If all the IP switch is off, it means the module station is number 1. And if all the DIP switch is on, it means the DIP it means the module's station number is 32. Okay, let's move to the relative instruction here. Is RS. RS instruction has the 2 function. It can be used in it can be used in user-defined protocol and model-bus RTU protocol. Here, I just mentioned the usage in model-bus RTU fund. Here we can see the IS instruction has 4 parameters. The first parameter is for the high bit. The high bit stores the station number, and the low bit is for storing the function code for the model bus. And the second parameter is the slave address for the address we want to read or write data. And the third parameter is the length. And the fourth parameter is for start address for reading or writing the data. We can see this example, RSH103. 1 means the slave address is the slave if we want to communicate with the model bus slave number 2. I need to set here is 2. And the lower 8 bits here is 03. 03 means reading the slave registers. It can be also be D 0A or 0F. It have a different function code. And the K10 here is the address we want to read. And it can be HA, so it's in the 10. And the K5 here means the number of register we want to be read. And the D300 is the start register. So here, the address 10, the value of address 10 will be saved in D300. And the value of address 11 will saved in D301, and so on. And then the last is for the value of address 14 will be saved in D304. And you can see the limitation of the number of module connections. For the soft limitation, one PLC can only receive a maximum of 16 expansion modules. And here we provide a table, calculation table here. You can download it from here. And you can use this table to calculate how many modules you can be connected to different PLC. Here is a detailed instruction, a detailed introduction. Okay, let's move on to the I/O module. Today, I just want to mention the two expansion modules, LX3V 4DA and LX3V 4AD. The first we look the LX3V 4DA. It takes the digital value and output the analog signal. And you can see it have the inductor here to show the module state and the state of different channel. So when the module is working normally, the error LED should be off. And the communicate LED is flashing. The 24-volt LED will also lighting. The link communication is also flashing. And the AD LED shows the different channel, the state. If the channel closed, the LED also off. And if the input analog is input digital is out of the range, it will flashing. This is wiring here. As we can see, sorry, here is the current output and the voltage output here. And the module have the standard I/O characters. The standard for characters for voltage output is when the digital input is 0, so the output voltage is 0. And if I input, the digital input is 200, the voltage output is also 10 volt. And for current output, there are two modes. For 4 milliampere to 20 milliampere, the standard character is when digital input is 0, the module output 4 milliampere. And if the digital input is 1000, the module output 20 milliampere. If we choose the current output mode is from 0 to 20 milliampere. So if the digital input is 0, it also outputs 0. And if the digital input is 1000, the module analog output is 20 milliampere. So the formula of gain and offset is here. And we made a easy demo to calculate in different situations. This demo is also can be used in LX5V. And let me show you how to use this demo. If we want to first we need to set the range of analog and the digital output. So the first we need to set the different constant here. For LX4DA, we can check if we use a different analog mode, it has a different constant. So here, if I want to use it as the voltage analog output mode, so I choose 1000 for consistent the channel 10. As you can see, 0, 1, 2 has the same constant. And if the range I want to set is from 0 volt to 5 volt, sorry, for 10 volt, just for the default value. And the digital input is from 0 to 200. And you can see it calculates the result. The offset is 0 and the gain is the 5,000. It's just the same as we can see here. And if I want to, the analog output is maximum is for 5 volt here. And it's also, I input is from input digital value, it's from 1 to 100. And it shows the gain, we need to set the gain value is 50,000. And if we want to get the 4 volt, it calculates we need to set the digital input is 80. This is the part of the buffer memories. It's just a part of the whole module. If you want to more information of this VFM, you can refer to our support center. Here it shows all the buffer memories. Now we can see a BFM0 is used to set the output mode. If we set it as 0, it means we set the module as the voltage current output mode. If we set it as 1, so we set the current output mode with the 4 milliampere to 20 milliampere. If we set it as 3, it means the channel we didn't use. We disable this channel. So we can see it here. In this instruction, TOK1, K0, H2100, K0, okay, K1 here. We use this instruction to set the channel 1 and the channel 2 is the voltage output mode. And the channel 3 is the current output mode, 4 milliampere to 20 milliampere. And then the channel 4 is also for current output mode, but it's different. It's from 0 milliampere to 20 milliampere. And the BFM1 to BFM4 is the output data for different channel. And the 8, BFM8 and 4 and 9 is for the offset and the gain setting command for different channel. And the BFM10 to BFM16 is for the different channels offset data and gain data. We can see this example programmer. First, we need to set each channel's output mode. And we set the data to BFM1 to BFM4 to make the module output the different analog signal. And the BFM29 here is the error state. If error occurred, we can use FROM command to read out the detail of the error. So let's see this video. Here I use the default gain and offset value. So if I want to get 8-volt and 8-volt output from this module, I need to set the digital input is 1020 and 600. So you can see it here, 1000 and 600 for output data channel 1. And I measure the voltage from the channel 1 is also 8-volt. Okay, let's move to the LX3 V4AD module. It's also the same, but it's just receive analog signal and convert them into a digital value. It's the same indicator light state. And there are some different wiring here. If we use this module for current input, we need to short connect V1 plus and I1 plus here, these two terminals. And for some 4 to 20 milliampere sensor, it just have two cable. It used to it also used to you also use for power supply, and we need to refer to this wiring. The 24-volt DC supply is the negative is connected to V negative, and the short connect V plus and I plus, and connect it to Y negative, and connect V plus and with the power supply and the just and the sensor. This is the different wiring for different sensor. Okay, this is also for the default analog input and digital output. We can also use the same. We can also use the same demo to calculate how to set the value of gain and offset. And if we want to get when the certain analog input and what's the digital output we received. Here, if we want to change the gain and offset value. The first, we need to set BFM21. Here I connect LX3V4AD module here, and you can see it. We need to set BFM21 is A to allow adjust offset and gain value. And after we set it, we need to set it as 0 to prohibit here. And the BFM1 here is also for the channels initialized. This is a key buffer memory here. Channel 1 to channel 4, the content number, and we get the average input value is from BFM5 to BFM8. Here is also the example program. The first, we need to permit to change the offset and again adjust. And the BFM22 is for the different channels offset and gain adjustment. And BFM23 is for the offset value. 24 is for the gain value. And after we set it, so we need to set 21 as 2 to finish the adjust setting. Here is another. Here I connect LX3V4AD module here, and I want the analog range is from 2 volt to 8 volt, and the analog digital value we get is from 100 to 1000. And here I also choose the channel content is 0, so its content here is also 1000. So as you can see, it calculates, we need to set the gain, the value of gain is 8000, and the offset value is 33. As you can see here, I set the BFM24 is 8000, and the offset value is 1334 here. And if I want the analog input is 5 volt, the digital value we get is 550 here. And as you can see, BFM5 here for channel 1, I here get the same value. when the module received the 5 voltage signal. Okay, here is today's training. Tomorrow we will continue with the I/O module for the digital input module and digital output module, and the I/O BD module, and the LCM module with the LCM 16LEX and the EY output, digital output. Let's see some questions here. Can you please use page module? Hello, sir. Do you mean you connect connect two BD module here? Okay, so you can see it here. Wait a moment. You are using LX3V, so this 4 registers is for module 1, and if you connect BD module 2, you use these 4 registers. I think you can get the channels data from these registers. As we can see it here. D8112 to D8114, D8115 is for module 1. So if you connect DB module 2, you need to read the data from D8116 to D8119. Okay, do you have other questions about today's training? As I just mentioned, you can get the LX3V BD module from this special register of LX5V. Yes, SD2010 to SD2013 is for the DB1. And if you connect with the DB2, you can get a video from SD 20205030 to SD 2033. Okay, does anyone has other questions? Okay, today's training okay, it will be finished. Please join the tomorrow's training with the same time. And thanks for everyone attend. Goodbye.